Welcome to the first video in a series of videos intended to help support sixth grade math students and their parents in getting help with math ideas. I am Mr. Hammy, and we're going to look at ratios today. We start talking about it. So, what is a ratio? So, a ratio is a comparison between two quantities and values. So what I have here on this picture is we got some watermelons on the top, and we got some cherries on the bottom. So the ratio of cherries can be written in a couple different ways. So um, first off, when we talk about ratios, we use some keywords. So we go um, quantity A, the ratio of quantity A to quantity B. Another way to say two is there's this many A's for every B. Another way to say it. And normally how we write these is with this notation A semicolon B, where the B means 2. So let's talk about here. What is the ratio of watermelons to cherries? So what we're going to do is we're going to count how many watermelons there are. So there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 watermelons, 2. In cherries, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 cherries. So there are 8 watermelons to 12 cherries, or another way to think about it is for every 8 watermelons I have, I should have 12 cherries. Now, what if I change the order? What if I wanted to go cherries to watermelons? Well, when it comes to talking about ratios, the order matters. So whatever is listed first always gets listed first in my notation. So there are, again, 12 cherries. So we put 12 first. Use a semicolon to denote the word 2. And then there are 8 watermelons. So there are 12 cherries to 8 watermelons, or for every 12 cherries I have, I should have 8 watermelons. So the order does matter. It's really important when we do these problems that we're going to read the directions to see what goes first and what goes second. So let's do a few examples. So we have a table over here. In this table, we have the grades you could get on a test. We have an A, B, C, D, and an F. And we have a number of students who got each one. So there's 4 students who got an A, 5 who got a B, 9 got C, 3 got D, and 2 got S. So the first question says, what is the ratio of students who received a D on the test to students who received a B on the test? So it was going to be D students to B students. That's how we'll write our ratio, because D was first. I look for the word to. D was listed to before 2, so it's listed first, and B was listed after it. So D, I look here. Well, there are 3 students who got Ds. So there are 3 D students. And B students, there were 5. So the ratio of D students to B students is 3 to 5, or for every student who got a D, for every 3 students who get Ds, 5 should get Bs. Okay, let's do another example on the same set of data. What is the ratio of students who received an A on the test to the total number of students who took the test? So here's 2. So we can go A students to total number, right? So in my table, there are 4 students who got A's. And then the total students, so we're going to have to add these up. 4 plus 5 is 9. 9 plus 9 is 18. So I like to add differently. 8 plus 3 is 11. 1 plus 2 is 3. So we got 3. And there are 2 ticks, so that's 23 students. So there's 23 total students and 4 of them got A's. So the ratio of students who got A's to total students is 4 to 23. Okay, you have to include the 4 in the total. Okay, let's do another example. So Cadence emptied his coin jar and he found he had 12 quarters, 15 dimes, 21 nickels, and 10 pennies. So what is the ratio of pennies to quarters? So pennies, there were 10 pennies, so 10 pennies to quarters, 12 quarters. So for every 10 pennies in the jar, there are 12 quarters. Okay, second one, what is the ratio of quarters to nickels? So there are 12 quarters, so it goes first. Nickels, there are 21 in the problem, so it goes second. There are 21 nickels. So 12 to 21 is my ratio. And the third one is what is the ratio of dimes to the total number of coins in the jar? So there are 15 dimes, 2, and so let's do some math on the side here. Let's find out how many totals there are coins. So we're going to add them together. We've got 7, 8 here. 1, 2, 4, 5. There are 58 coins total. A second. So 15 to 58 for every 15 dimes, it should be 58 total coins. Okay, so the last problem, we got sort of the same setup as the first example. Now we have added some grapes. So there are 3 questions. I would challenge you to pause the video and try these questions yourself. Okay, so the first question, what is the ratio of cherries to the total number of fruit in the diagram above? So cherries are at the bottom, so there's 3, 6, 9, 12 of them. So 12 total cherries. So 12 cherries. And the total number of fruit. So there's 12 cherries. There are 8 watermelons, so 12 plus 8 is 20. And there are 4 bunches of grapes, so 20 plus 4 is 24. So the ratio of cherries to total fruit is 12 to 24. What is the ratio of watermelon slices to the total number of fruit? So watermelons first, so there are 8 watermelon slices, and there are 24 total fruit in the diagram. So the ratio is 8 to 24. For 8 watermelon slices, there should be 24 total pieces of fruit. So the last one is 2 questions. What's the ratio of grape bunches to watermelons? Let's do that first. Grape bunches to watermelons. So there are 4 bunches of grapes to 8 watermelons. So again, grapes go first, watermelons go second. So the first part is 4 to 8 is the ratio. Then the second one is the ratio of cherries to grape bunches. So there are 12 cherries and there are 4 grape bunches. All right, so there is an introduction to some initial thoughts about ratios. In the next video, we'll look at how to find equivalent ratios and different ways to visualize and think about ratios.